So in this last video, we're just going to take a look at a couple more examples. So we're going to use these values that we have in our unit circle. They're just going to be a little more difficult for us to break down. So when we look at this one right here, we have 2 sine of 2x, cosine of x minus sine of x. So I hope you realize as soon as we see this right here, this 2x, that is actually values that are dealing with double angle. And we've talked about our double angle identities. We know that sine of 2x, our double angle, is 2 sine cosine. I forgot my x in here. So we're going to be able to actually put that in to that position. So I have 2 times 2 sine x cosine x. So remember, I took this highlighted yellow section right here and just plugged it in right here. I'm leaving everything else the same. So then I still have my cosine on the outside and then minus my sine here. So one thing that we can do is go ahead and multiply these values together. So I know 2 and 2 will give me 4. I have sine, I only have one of those, and then cosine times cosine is cosine squared. And then I still have my minus sine of x. And then really start thinking about this like we have in several of the other examples. Is there anything we have in common? Can we factor? What could we actually take out? So I notice that they both have sine values in them, so I'm going to take out a GCF. So sine of x is 4 cosine squared minus 1, because I divided a cosine out of each piece. And now that I have these separated into parentheses like this, I can set each value equal. So I know sine of x equals 0, and then this one's going to take a little bit extra work. 4 cosine squared of x minus 1 equals 0. So I'm going to bring this one up here because we know that this value is done. There's nothing else for us to solve for, but the other one I am going to have to do a little bit extra work. I can go ahead and add 1 to both sides, where I have 4 cosine squared of x equals 1. So now we can go ahead and divide by 4. And this is going to look very similar, y'all, to a lot of the problems we've done already. So I have 1/4, and then I take the square root value. And remember, when you take the square root here, we always do plus or minus, and this will give me 1/2. So I hope we don't have to look this part up again, because almost like 2 or 3 examples have had these same solutions. So we would get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Remember, those are just from your unit circle. I'm finding everywhere that cosine is 1/2. So all of my denominators of 3 give me those values. And then I do know my purple right here, sine x equals 0. I haven't done that yet, which is just 0 and pi. So you technically get a total of 6 answers for this problem. 0, pi, and then pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So you have to include all of those values and put them in there when you're doing your MyLabs Plus work. Okay? And then finally, our last example for this video is secant squared x minus 2 tangent squared x equals -2. Now there's a lot of squareds here. These are not the same values, so we can't just put them together. But think about this. Is there a way for me to turn secant squared into something that has tangent in it? And if you remember from Pythagorean, I know that 1 plus, and I'm going to erase some of this up top, so if y'all need to pause the video and go back to it, it'll be up there. But I'm going to get rid of some of this so we have some room. I know from the Pythagorean identities that secant squared is equivalent to 1 plus tangent squared. And it'd be beneficial to put that into this problem since we already have tangent squareds. We would have more like terms to deal with. So I'm going to substitute that in. I'm going to have 1 plus tangent squared x that I just substituted in. I'm going to put parentheses just so you know that's what we substituted. Minus 2 tangent squared x equals negative 2. And now that I have tangent squares, they're like terms, just like having x minus x. So I have 1 tangent squared minus 2 tangent squared. So I will end up with 1 minus tangent squared, because 1 minus 2 will give me a negative 1, still equals negative 2. And then we can continue to solve it from here. So subtract 1, so negative tangent squared x equals 3. But I do have this negative here. I'm sorry, this is a negative 3. I do have this negative, and if I divide by negative 1 to cancel it off, I'm going to be left with tangent squared x equals positive 3. And then finally take the square root value. So tan of x equals the square root of 3. So this is what I'm going to be looking for on my unit circle. And we've done some similar problems like this. You just have to realize that, or remember, that tangent is sine over cosine. So when I divide those values, I want to be left with the square root of 3 up top. The other thing that would help us out here is tangent is positive. So when I go to my unit circle, I want to know when tangent is positive. Well, tangent, all students take calculus. Tangent is only positive in the first and the third. Okay? Now, I'm going to have to backtrack a little bit, and I apologize for this. And I hope somebody called on when you were watching this. I did make a mistake. So if I go back here, when we take the square root of something, what should we always put in front? When we take the square root, it should always be a positive and a negative in front, a plus or minus. Sorry, I forgot to do that, but we've done that in our other videos. But remember, every time you take a square root, you should get a plus or minus value. So now when I go back to my unit circle, I should be looking everywhere because I'm either getting a positive or a negative. So that will be in every quadrant. Now to get square root of 3, okay, when I have sine over cosine, this is where I'm going to be looking to have my sine value have an actual square root of 3 in it. So that's where we would be looking at values like pi over 3. And the reason for that is because if I did sine over cosine, what happens to my denominators? They will cancel, and I'm left with square root of 3 over 1, which would be just square root of 3. So that will work out just fine for us, and I can leave it like this. So every time I see that happen, and you know you have pi over 3 here, it's just going to reflect. So every time that I see my denominator of 3 with a reflection there, those would all be solutions. Because even though I have a negative 1/2, remember we're looking at either a positive or negative square root of 3. So that should also work for us. So all 4 of these values would be my answers. So I would get my pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And remember, it all depends on if I'm asking in radians or if I'm asking for this actually in degrees. And you're more than welcome to try this one on the calculator. This one gets a little bit trickier because you can't type in secant. You would have to type in cosine. So that's why I think usually a lot of times it's a lot quicker to work it out by hand.